Triptych Algebra. In this video, we're going to talk about solving quadratics using completing the square. Before I actually get into the full-blown completing the square problem, I need to cover two topics first. First thing we need to review is how to solve an equation using the square root. In this quadratic equation right here, I can solve with the square root. If I apply the square root to both sides of the equation, I'm doing so because the square root will cancel this square right here, leaving me with x minus 7 equals, importantly, plus or minus 4. This gives me two different equations. This is now x minus 7 equals 4 and x minus 7 equals negative 4. I can solve both of these equations to get my two solutions, to get x equals 11 and x equals 3 are my two solutions for that original equation. Again, the emphasis on this move is getting this plus or minus whenever I apply any even root radical, specifically in this case, this square root radical to both sides of an equation to solve. Next thing we need to review are perfect square trinomials. Perfect square trinomials are the result of squaring a binomial or multiplying it by itself. They importantly have this similar form. Here's an example. If I take x plus 5 and I square it, which by the way is x plus 5 times x plus 5, and would usually require me to FOIL and then simplify like terms, but using that formula, what I'm going to get is x squared plus something times x. That something is 2 times a, or in this case 2 times 5 to get this 10, plus 5 squared, which is 25. For one more example, if I had x minus 4 squared, the resulting multiplication would be x squared minus 2 times negative 4, which is negative 8x plus 16. Importantly to note, that last term will always be positive. This formula does work for both of these cases. A can be any integer. For instance, in the middle term, 2 times a was 2 times 5, which gave me 10. And in the second case, 2 times a was 2 times negative 4, which gave me the negative 8. All right, let's now get down to the good stuff. We're going to solve this quadratic equation by completing the square. Before we do that, though, the question may be, hey, we already have the technique of factoring. Why would we need to solve this by completing the square? Importantly, equations that can be solved by factoring are kind of manufactured. They're set up so that you can factor. Very often in mathematics and in sciences, we'll have equations that look like this, quadratic equations that we cannot solve by factoring. Specifically in this case, there are not two numbers that multiply to be negative 41, but also add to be a positive 6. Here's what we're going to do. We're going to create one side of this equation to be one of these perfect square trinomials, which will then factor in this perfect way into a form like this that you'll see. Finally, we're going to use the square root technique that we first talked about in this video to solve that equation. First and foremost, what I'm going to do is add 41 to both sides. I'm doing this because I'm trying to set up this left-hand side of the equation to become a perfect square trinomial. What I need to do is to add the specific constant, the specific number here, to make this a perfect square trinomial. This won't be too hard, actually, if we understand this formula right here and how these two coefficients relate to each other. Our first step is to find this a value. The a value is always half of this b coefficient, or the linear coefficient. So in this case, a equals 6 divided by 2, which is 3. That will be important here in a second. Now what I need is a squared, because that's what I want to add on. So a squared in this case is 3 squared, which is 9. This is the number that I want to add to both sides of this equation. So I'm going to add 9 here to make this a perfect square trinomial, and over here I'm also going to add 9. So this leaves me with x squared plus 6x plus 9 equals 50. It may not feel like we've done much, but here comes this beautiful move. I've now created this to factor perfectly into x plus 3 times x plus 3, or specifically, this now factors into x plus 3 squared. This other side is not 0. Over here, it's 50. The beautiful thing is I don't need this side to be 0 as in when I'm solving by factoring the quadratic formula. All I needed was for this to factor perfectly into a perfect square. And why that helps is again because the awkwardness of having multiple terms that have an x in it. Once I factor it like this, the x only appears once, and simply now I can apply the square root and then add or subtract to isolate my variable. So now I simply apply the square root to both sides of this equation. This will give me x plus 3 equals plus or minus the square root of 50. The square root of 50 can be reduced. I'll reduce that to be 5 times the square root of 2. Just on the side right here, 50 would be 25 times 2, which equals 5 times the square root of 2. So let me replace that. Finally, all I need to do is subtract 3 from both sides to get my 2 solution, which is negative 3 plus or minus 5 square root of 2. These are the exact solutions. I could find approximate solutions by plugging the square root of negative 2 to my calculator and evaluating these two. Again, specifically, this is negative 3 plus 5 times the square root of 2 is the first solution. The second solution is negative 3 minus 5 times the square root of 2. It's better almost always to provide the exact solution here, and you may notice solutions of this type are very similar to the solutions we got with the quadratic formula. A quick recap. First, what we do is we move over the constant. We move the constant over to provide a space to make this a perfect square trinomial. Once we've made this a perfect square trinomial, we then factor it perfectly. It becomes x plus 3 times x plus 3 in this case. By the way, that 3 value we have is the a value we find in the first step over here. That's why it's always important to keep that on the side. Finally, we do whatever operations we need, including the square root and other additions or multiplications, subtractions or divisions, to solve for our x value.